All right, so let's now talk about some reminders. Your classmate might still be arriving. Let's now talk about some important stuff before we talk about technical stuff. And just don't forget your lab number 2 is due tomorrow at 12 noon. And if you haven't really seen the video solution, I would suggest take a look if you need any help on walking over the solution with you for lab number 2. The solution video and the grading test are already there. If you cannot find them, let me know. And for your lab number 3, that one is going to be a relatively simpler lab, so it will only take you 1 week to complete. I think it's a rather simple one, and we're going to save the more struggle and learning maybe for lab number 4 and 5. That one it will be much more substantial. And we can, for lab number 3, just make sure it take less than 1 week to complete it. And for your programming test number 2, it will be next Wednesday during your scheduled live session. The only tip I'll give to you would be make sure you know how to do things like a practice test 1, and also you know how to do exceptions. That's really important. So the best preparation for programming test number 2 will be to redo lab number 2. That'll be the best preparation. And you may also want to maybe go back to, if necessary, the basic OOP review kind of stuff, like PDFs and also tutorial video. Everything is kind of connected to each other. It's really hard for me to say don't look at those, right? So you really want to take a look if necessary. All right, do you guys have any questions about the course in general? All right, if everybody's good, let's do some quick recap about what we spoke about on Tuesday. All right, so on Tuesday, we basically still continue with the object equality lecture. Let's see what we said. We should be able to get very close to the end of the object equality lecture today, but we'll see. So we reviewed this particular example about static type, dynamic types, and typecasting. Very crucial for understanding phase number 4 for the equals method. All right. And then we spoke about the overridden version, basically phase number 4 here, especially how do you use, sorry, this is still phase number 3. How do you use the get class method here? Briefly speaking, the get class method here is going to return the dynamic type of the context objects. And if you really want to make sure you compare apple with apple or banana with banana, you have to make sure you use a get class method. All right, that's something we spoke about in very much detail last time. You can refer to the recording if necessary. And we went ahead to talk about, that's just one example for phase number 3. That's fine. Well, you can see, for example, here, you're comparing P1, which is a point V2 objects here. And then you're comparing S, which is a string, right? You're comparing apple with banana. It should be false right away. And we spoke about this kind of logic here. What does it really mean when you are able to reach the beginning of phase number 4? What does it really mean? We actually got a list of items over there for you to get convinced, right? Also, you want to review them. And let's see. And that's really phase number 4 about the typecasting, all right? And without the typecasting, you wouldn't be able to use without the typecasting, you wouldn't be able to use obj alone.x or obj alone.y because its static type is simply just objects, right? We said that when you declare the static type, it really determines the methods you can actually invoke on that objects, right? Always remember that principle. And a little bit look ahead, which really is something I'm going to emphasize many times in the coming inheritance lecture, which hopefully will start next Thursday. For the static type and dynamic type, you have to use these 2 types to really make different decisions. Let me just mention that without writing them down. I'm going to write them down a little bit later. For static type, it's really for determining if your piece of code is going to compile, only for compilation. Whenever you want to determine a piece of code, is it going to compile, always look at static type. Let's say your code compiles and you are able to run it, let's say on Eclipse. What's going to be the runtime behavior? For example, what will be the version of the equals method that's going to be invoked? Should it be the version from the object class, or should it be the version from the point V2 class? In that way, you have to look at dynamic type. It's why it's called dynamic runtime. Compile time, static type. Runtime, dynamic type. All right? That's something we'll keep repeating. All right, so that's basically example for phase number 4, right? So I don't need to repeat them. And then we talk about the difference between the overridden version, which compare references, and also, sorry, let's say it again. We compare the default version, which compare references, and also the overridden version, which will compare the contents, right? Make sure you also know that comparison. And we talk about object equality versus reference equality. And there should be a logical implication relationship between them, which we spoke about too. All right, so let's see. And we talk about the requirements for the equals method. This is just one of them. And we talk about the assertions. Assert the same is pretty straightforward. It just compare references. You boil it down into expression 1 equals expression 2. And when you have assert equals, it gets into different cases. Case number 1. If both expressions are primitive type, in that case, it will simply just be equal, which wouldn't compare references, of course. It's going to compare the primitive values. And if you got reference type for expression 1, expression 2, this is where things can get tricky. Because if you remember the summary notes that we went over here, the essence of it is as follows. If you got assert equals here, but you got expression 1, expression 2, versus expression 2, expression 1, by swapping the order of the argument, it's going to make a difference. The difference would be, in case number 1, if you put expression 1 as the first argument, it will boil down into expression 1 being the context objects. So expression 1 dot equals. If you put expression 2 as the first argument instead, it's going to be expression 2 being the context objects. So it will be expression 2 dot equals. So now, if you look at case number 1 and case number 2, which version of the equals method is it going to call in case number 1? It depends on the dynamic type for expression 1. What about for case number 2? Which version of the equals method is it going to call? It depends on the dynamic type for expression 2. Right? That's why it is so important. All right, I would suggest let's now see some example which I didn't quite finish at the end on Thursday. I didn't want to rush it too much. Why don't we just review that very briefly? But this example here actually is going to be repeated very soon. So very quickly. I want you guys to look at these 2 lines. All right, only these 2 lines. And then the question you want to ask yourself is as follows. Oh, only these 2 lines. Okay? Which version of equals will be invoked? Let's say this is option number 1, or let's say this is line number 1. Let's say this is line number 2. 1 and 2. Before I go any further to analyze it, can anybody tell me, for line number 1, which version of the equals method is going to be invoked? Just one. I got options for you. It could be the equals method from the object class. It could be the equals method from the point v2 class. Or it could be the equals method from the string class. These are basically equals methods you have seen so far in the course. But of course, there could be many more, depending on how many classes you have. Right? Anybody? Take a guess for 1. From point v1? Yeah. How did you judge? Yeah, okay, that's good. So, all we gotta make sure is you want to know what's the dynamic type. P2 over here. This one here. Dynamic type for P2, as you can see, it will be just point v1 objects. Right? If you draw the diagram, you're gonna see that it points to some point v1 objects. Dynamic type is point v1. So we're going to call the version in point v1. However, there's no explicitly overridden version of equals in point v1. That means we're going to find the one inherited from the object class, right? Object version. That's pretty good. And let me just say up to here, right? I'm going to trace a little bit more detail in some follow-up example. What about number 2? P3 here. P3 here, I'm going to answer for you. P3 here, dynamically, is a different type. You can see P3 dynamically is now pointing to point V2. So that means we can write something here, right here. The dynamic type is actually point V2. That means we're going to call the point V2 version, which is the version that we have been speaking about, the overridden version. Of course, you should really trace in detail how these two lines are going to be executed differently. But we got very similar example in just one moment, so we don't need to repeat. Let me get there and trace together with you. All right, any question so far? So far, the most important principle you need to know is which version of equals are you going to execute? It depends on the dynamic type of the context objects. All right, that's the number one principle you want to remember. All right, if no further question, let's now move on. And let's now do more examples, right? I would say the first set of examples will be a little bit easier one. We only got simple attributes like x and y. And after this, I will move on to defining another two classes, namely person and also person collector. And we're going to see how we can deal with reference type and also array type, right? That's more realistic in your application and also for your lab number 3. Let's now start with something simple, right? So for part 1, for the example, we are only talking about point V1. There is no overridden version. So we're going to most likely execute the equals method here from objects. Okay, very quickly. So now we got P1 over here. That one has 3 and 4. And we have P2, which has 3 and 4 as well. Straightforward. And then if you try P1 equals P2 should be false. No question about it. And since we are asserting false, that means it's going to pass. All right? Let's now move on. And P2 equals P1, that one should also evaluate to false. And since I'm asserting false, it's also going to pass. All right? Hopefully there's no confusion there. All right? And if you like, you can also try to call assert the same. If you say assert the same P1 and P2, this will boil down into P1 equals P2, right? It's going to be fail. Because P1 equals P2 is going to give you false. Assert the same false will be fail. Versus if you say assert the same P2, P1, this will boil down into P2 equals P1. And we know that that expression there is false. Assert the same false is going to fail. All right? So there is really a notion here. Whenever you're evaluating a Boolean expression, you would say either true or false. However, if you're running a JUnit assertion, it's going to be pass or fail. Right? Just be careful about the terminology you're using. Right? Precision is important. All right, let's now move on. And why don't we try, let's say P1 here. P1 dot equals P2. Obviously, P1 is currently pointing to point V1 object. That's a dynamic type. So we know that this one here is going to invoke the object version. So it would be as if we set P1 equals P2, right? Which is false. Assert false is going to be pass. And another one here. Now the context object is different. So if I try here, so P2 dot equals P1 over here. And we know that P2 is currently pointing to some point V1 object here. So dynamically, it's also point V1. So in this example here, it's pretty simple. We don't really have any other context object type, but in some later part, they would be different. So you really have to judge carefully. But let's finish this one. So this one here is also going to be invoking the object equals. And it's going to boil down into P2 equals P1. And you should definitely notice that the order of the equality is a bit different. Here is P1, so that's why P1 comes first. Here it is P2, and here P2 comes first. Right? Any question about this? That's a part one. Should be straightforward. Okay, part two. Let's now move on to the version where we got overridden equals. So we got object version. Also, we got the overridden version. That's in point V2, right? That's something we're pretty familiar with. Let's now get right to the point. We got P3 over here, and that one there will be 3 and 4. And notice that the dynamic type is point V2, right? Only up to here. That's the dynamic type. Dynamic type. And we got, let's say here, P4. That one there, dynamic type is also point V2. Dynamic type is also point V2. Dynamic type. Happen to be the same. And this one here, straightforward, P3 equals P4 should be false. Assert false should be pass. P4 equals P3, different objects, so it should be false here, assert false, pass. Similar as before. And if you try assert the same, P3, P4, this will boil down into P3 equals P4, right? It's also going to fail because it evaluated false. Let me just say one thing here, just in case you're a little bit confused. If you look at, let me highlight it. If you look at this line here and this line over here, right, the orange one. If you look at assert false, and then P3 equals P4, versus if you say assert the same, P3 and P4. Both of them will boil down into evaluating P3 equals P4. However, the difference is, in this case, because this expression here evaluates to false, so assert false is going to be a pass. In the second case, this is going to boil down into P3 equals P4. In that way, it's going to give you false. However, when you say assert the same, it tells you they are not the same. It's going to fail, right? Notice the subtle difference over here, right? Depends on what I might put in the lab or in the programming test or even in the test. You have to know which one you're supposed to judge. Evaluating a Boolean expression to be either true or false is different from passing an assertion or failing an assertion. There are orthogonal issues here, okay? Okay, so I hope that's clear. All right, let's now move on to just one of them. Similar to the previous one, I think the next part will be more fun. How about this one here? So now we try P3 dot equals P4, and dynamic type, as we said, is point V2. So we know that it's going to call the point V2 version. All right, and when we actually call this one here, what's going to happen, right? So when you trace P3 dot equals P4, it's going to call this version over here. And if you try to do the checks, which I'm not going to repeat, we did that many times, the objects are not the same, so we don't return true right away. OBJ is also not equal to null, so we don't really return false right away. And we are really comparing two things with the same dynamic type. So the get class are going to return the same thing. So we are not also going to return false. We are not. Okay? So what we'll end up doing is only this part here. We're just going to compare their values. Okay? And there's something I can fill out quickly. So 3 and 4. 3 and 4. So what we'll end up doing is we're going to compare just this part. And that one there, you can see 3 and 3, 4 and 4. So that should be true, right? So they are the same point V2 objects. And for this one here, you can think about this version here really is going to execute this part over here and then give you true. All right? And you can do a similar reasoning, which I'm going to point very quickly. If you try to analyze this one here, similar, but except that it's now going to be P4 being the context objects. But the same version is going to be called because P4 dynamically is also point V2. Right? Similar logic here. So we don't need to repeat here. So when you study the code over here, always remember to ask yourself, which version of the equals am I calling? If you get that part right, it's hard to get wrong later. All right? All right, any question about this? Good? All right, good. Just want to be sure. Now, this one's more fun, all right? I promise. All right, so this one here, we got two, point V1 and point V2, put side to side, side by side. Let me make it a little bigger. Let's now, first of all, look at P1 here. So for P1, dynamically, it's a point V1 objects. So we're going to put here. Point V1 objects. It's dynamic type. 3 and 4. 3 and 4. Good. And then we got point V2, P2. And dynamically, it's a point V2 objects. So dynamically, you can see it's now a different dynamic type. Dynamic type here. Also, it's going to be 3, 4. One thing I would like to clarify right away. Intuitively, you might be thinking, well, when I look at the box, I got 3 and 4, I got 3 and 4. So maybe they should be considered as content equal. No. All right? It's simply because you're basically saying apple and orange. Somehow they have some attributes sharing together, but it doesn't really mean apple is apple. So apple is banana, right? My point is, whenever you're comparing objects, you want to make sure you're really comparing the same type. If they are different types, it doesn't really matter if they may have stored some same values internally. Doesn't matter. It should be false right away, right? That's something you will see. All right, let's now, before we go to the equals, let's now try to trace a little bit here, okay? We got two assertions here. I'm going to make it a little bigger. Okay. Can you guys tell me, let's say this. If I got this one here, it's an assertion, assert false, and you know what it means really, really well. Let's say this is number 1. I got another one here, assert false. That's number 2. Okay, tell me the outcome of running assert false, number 1, and assert false, number 2. What's the outcome? Let's start with number 1. Pass or fail? I heard pass. Because you think P1 and P2 are different objects, right? Okay, anybody else? You're getting close, but not quite. It doesn't compile. Oh, that means you wouldn't even run. How come?
Because you can't compare objects that are different types.
All right. Guys, this is tricky, but you need to know. All right? So the answer is, this is not even going to compile. So there's no fail or pass option here. Because when you are explicitly writing down some Boolean expression over here, I want to compare the references or addresses between P1 and P2. But the way Java compiler looks at that, you declare P1 to be point V1. You declare P2 to be point V2. You cannot compare two things. They are different types. As straightforward as that. You just cannot. What might happen at the runtime is, if you try to say assert equals, in that way, you might boil down into comparing the references between P1 and P2. But that's not a story. That's implicit. It's not something you wrote directly. But if you want to write something directly, you cannot write to compare the references between two different types. You just cannot. All right? Compilation error. Other than that, we look at assert the same. This is what I was talking about. So here, this is kind of implicit. Assert the same, if you go back to the definition or declaration for the assert the same, they take object and objects. They can take anything. So now, even though P1 and P2, they are different types, but you can definitely put them here because they are objects. Now, this will boil down into, which I put in quote, P1 equals P2. So now, we can have something to say. There will be no compilation error. But should it pass or fail? Now I can get back to you. You'll fail. I agree. All right? Because it's going to evaluate to false. Thank you. All right, again, you want to be very clear about why this assertion here will not even run, compilation error. And why this assertion here looks pretty much doing the same thing, I agree, somehow, but this one here is going to fail. All right? It will run, but it will fail. Okay, similar story for P2, P1, which will boil down into, I can write it down, boil down into P2 equals P1, which is going to fail as well. All right? And the final two lines are the most fun one that can nicely conclude the recap that I just said in the beginning. All right? Now, we want to look at these two lines. And I want to give you enough context so you can stare at that for just 1 minute, right? You really want to think it through yourself before I start explaining. Okay, I think that's good enough. I want you guys to look at these two lines. Let's say, okay, this one here. This line here. Oh, let me do a little bit better. This line here. And this line here. The red and the green. All right? I can tell you one thing first. For red and green, both of them are going to pass. Both of them. And simply because the equals method will just return false because we are asserting false. If I tell you that both of them pass, that means the equals method here and the equals method here both return false. That's something I can tell you. All right? So now here's a question. Do the two equals method return false for the same reason or not? When I say for the same reason, you can think more concretely. Are they going to be executing the same line of code to return false? That's the question. All right, look at this piece of code here just for just 1 minute. All right? I really want you to think it through yourself, even though you might be struggling a little bit. But that's important. Right? Both of them should return false. But are they really returning false for the same reason by executing the same line of code? Anyone? All right, number one. Are they returning false for the same reason? Not the same reason, right? Okay, maybe. You're guessing, okay. But if for different reason, what's the reason for the red one to return false? From where? The object class, okay, sure. Because over here, you can see P1 over here dynamically is pointing to point V1 over here, as you can see. So that's why, let me put a star here. For the star, it's going to do P1 dot equals. Oh, let me just say this. And that one there is going to call the object version. And which will boil down into, I'm going to make an annotation here. So this version will be called. And that one there is simply doing P1 equals P2. And of course, it's going to give you false. That one's easy. Okay? But you just got to know which version it is. What about number two? Well, number two, let's now help you a little bit. Because I know for number two, let's say star, star. I'll put it here. For number 2, if you try to call P1 dot equals P2, I know that dynamic type for P2 is point V2. So I know that it's going to call the point V2 version. Point V2 version, which will be over here. All right? Over here. And then, if I'm calling this version here, can you tell me which line is going to return false? Which line? Right? I'm talking about this, right? P2 dot equals P1. And I know that P2 is this. P1 is this. And now I know that I'm executing this version of the equals. But now which line over here is going to return false to me? Is it this line here? Or is it this line here? Or, okay, you say yes, okay. Or is it going to be something like from here? Right? There are 3 possibilities, right? All right. Okay, the flow goes like this, but the answer should be here. Exactly here. All right, because you can see here we're checking to see this dot get class, which is corresponding to P2 dot get class. That one is going to give you back point V2. And also we got P1 over here, so that's the arguments, the OBJ, right? So OBJ dot get class is actually going to give you back P1, sorry, point V1. So now if you compare these two, they are not equal to each other. So this will be true, so return false. All right? That's why. Question?
I think there's a little typo after the 2 asterisks. It should be P2 that equals P1, right?
Yes, I agree with you. Thank you. That's important. I absolutely agree with you. Thank you. Good. All right. All right, so the most important 2 lines for you to really study and convince yourself would be these 2 lines to know exactly which one is going to be, which version of the equals will be called, because dynamic type for context object 1 and context object 2 are different. Okay. All right, any follow-up question to this, guys? Yes?
Would it also check if the 2 objects are equal? Because the equal method that we provided, we already checked if they're the same class, right? But the default method
The answer is no. Okay, the question was, does the default version of the equals method from the object class check the dynamic types? No. Well, as we have seen, this is the entire definition for the equals method in the object class. Does it call any get class? Not really. They check something very strong. Are these 2 the same objects? Okay, that's it. So this is the default version that's always fixed over there. There's no way you can change it. If you're not happy with it, override your equals method. Right? That's the logic. Okay. Alrighty. If no question there, guys, I think we are getting very close to the end about the equals method. I think the rest will just be more example, just to reaffirm your understanding. But we should definitely do more example. Okay, so really no follow-up, right? I'm going to switch the subject slightly. Good. And before that, I would like to ask you guys one thing. For those of you who may have learned about discrete math, right? You know in math, you got things like P and Q. P or Q. You have seen that before, I'm pretty sure. Okay? Versus, if we talk about Java, or just programming, you know the corresponding operator, P, ampersand, ampersand, Q. P, vertical bar, Q. All right? Here's my question for you. Yes or no? Are the logical operators, conjunction, disjunction, really equivalent to the programming operators, ampersand, ampersand, and vertical bar? Are they 100% equal to each other? 100%. But of course, if I ask you this, right, you pretty much know the answer. But you can tell me. You think 100%? I like the answer, okay? But it turns out they are not the same, okay? Sorry. All right, so have you guys heard about something called commutativity for operator? Don't worry about the name, I'll show it to you. There's something called commutativity, which means if I got P and Q in math, it should be equivalent to Q and P. Agree? Doesn't matter which side you consider first. However, if Java was equivalent to math, then we should expect, for example, let's say n%, P and Q should execute the same as Q and P. Agree? But in fact, no. No. So that's something not equal to each other. That's something I would like to talk about. Okay? This is something called short circuit evaluation, which is quite useful. All right. In order to actually talk about the next example for equals method, I'd like to talk about this one first to make sure everybody is okay. All right? All right, short circuit evaluation. And it will apply to both the n% and vertical bar. All right, let's now talk about it. This one, I'm pretty sure you have seen before, right? Truth table for conjunction, right? Can I just bother you with one fact? The only way for you to make the conjunction true is when both operands are true. If any one of them happen to be false, the result will just be false no matter what. It's a very important observation for conjunction. All right? Now, when we consider, let's say, two expressions, if I have, let's say, expression 1 and expression 2. Of course, expression 1, expression 2, they're both Boolean. At a runtime, there are two principles you want to follow. Number one, evaluation is going to go from left to right, always. Evaluation will be from left to right, always. You basically evaluate the left-hand side. Whether or not you evaluate the right-hand side depends. All right? Now, let's talk about two cases. 2.1. Let's say I evaluate the left-hand side, meaning that I evaluate expression number 1. And that expression evaluates to false. Logically speaking, if I know from these two rows over here, if I know that the first expression already evaluated to false, does it really matter what the second expression is? No. The result is going to be false anyway. So Java takes advantage of this fact over here. So if the first expression evaluated to false, we're going to skip the evaluation of, so when I say L, I really meant expression 1. Skip the evaluation of expression 1, expression 2, sorry. And then the n%, the whole thing is going to evaluate to false. Okay, let me recap. Let's say you want to evaluate this at the runtime, left to right. If I know if somehow this already evaluated to false, don't evaluate this anymore. Just return false for the entire conjunction. All right, that's case number 1, 2.1. What about 2.2? 2.2 goes like this. You still want to evaluate expression number 1, always from left to right. And somehow it gives you true. And it will now nicely correspond to the remaining two rows over here. If I know that expression number 1 is actually true, I really need to evaluate this and the expression 2 as well, because if the second expression is true, the result will be true. If the second expression is false, the result will be false. So it really depends. So I really have to evaluate it. Don't skip. So we're going to evaluate expression 2. Okay? And the result is going to depend on that. All right? So short circuit evaluation tell you that you may skip the right-hand side in some cases. You might. Okay? Any questions so far about this? This is only the case for conjunction. Let's now do the case for disjunction, right? But they're symmetric. Let's say I want to evaluate expression number 1 or expression number 2. Step number 1, you have to evaluate from left to right. Same as before. Evaluate from left to right. 2.1 over here. Let me use a slightly different color, maybe a little bit brighter for you to see. 2.1. Let's say the left-hand side, expression 1, evaluate to true. Let's say you try to evaluate expression number 1, and then it gives you true. Now, it will correspond to this line over here, and also this line over here, where expression number 1 is simply true. In that way, does it really matter what expression number 2 is? Doesn't matter, because the result will just be true anyway. Right? So what we do is we're going to skip the evaluation of expression 2. And then the OR expression is going to return true. All right? Kind of symmetric, right? You can see here we talk about evaluate to true. So here we talk about evaluate to false. Right? Here it's going to return false for conjunction, and it's going to return true for disjunction. Right? Symmetric. Okay? 2.2. So 2.2 here, to be complete. What if we evaluate the left-hand side, expression number 1, and it gives us false? It's now going to correspond to this row over here, and also this row over here, 1 and 3. Okay, this one here and this one here. If the left-hand side is already false, we really have to evaluate here, because if this one is false, the result is false. If this one is true, this one is true. So we really have to do it. Okay? We cannot skip. So we still have to evaluate expression number 2, and then return the result accordingly. This is a little bit dry, I agree, but that one really tells you the reasoning behind, because short circuit evaluation, as you can see, if you got the true or false wrong, you're going to interpret the expression in the wrong way. So that's why I got to talk about it first. Okay? Of course, that relies on your thorough knowledge about the truth table for conjunction disjunction, which we assume. All right? If you are not feeling comfortable, you may want to look at the truth table and convince yourself, or reach out to me if you need some more information. All right, any question about just about a short circuit evaluation? I'm only talking about definition. I'm going to see how it can be used. All right? So the use goes like this. Let me sketch it, and then we'll see example. How do we really make use of short circuit evaluation? Okay, I'll give you both conjunction and disjunction, 1 and 2. All right? It goes like this. Usually, we say that if you have some expression number 2, I want to evaluate it. However, expression number 2 contains some vulnerable or sensitive expression that might cause crashes or exceptions at the runtime. Okay, for example, expression 2 might be doing some, for example, y divided by x. And we know that this expression is not always well-defined. from math, right? If x happen to be 0, then it can crash. You cannot do division by 0. Also, if you are trying to evaluate array A at index I, this is also not always working, because if, for example, what if it's negative? Well, I may be too large for array A. In that case, you can also get array index out of bound exception, right? So these are just 2 examples where things might go wrong. Right, just expression 2 alone. So short circuit evaluation can help us to say, let's say I want to protect expression 2 from crashing. If I put that together with conjunction, I'm going to put another expression over here, expression number 1. And expression 1 is what we call guarding constraint. Or protecting constraint, whichever way you like to call. Guarding constraint goes like this. If this expression here evaluate to be true, I know that it's 100% safe to execute the expression here. If somehow this expression 1, the guarding constraint evaluate to false, I shouldn't go ahead and evaluate this. That's exactly what short circuit evaluation is going to give to me. Right? So that's why you want to understand why we're doing this and how the short circuit evaluation can help us exactly doing that. All right? And I'm just talking about principle, and then we'll do example in just one moment. And then I'll give you some exercise to try. Well, so let's say we got expression number 2, and then again, that one there may have some sensitive expression like these, right? Things that might go wrong. And now I want to put that together with OR, which has similar logic, but just kind of symmetric, right? So now in this case, this would be expression number 1, and this is what I call error condition. How does it work? If the error condition, so let's say, for example, let me just give you a little bit further detail here. If I talk about y divided by x, what will be the guarding constraint? It would be x not equal to 0. This is to say, if x not equal to 0 is true, that means I will be able to evaluate y divided by x without division by 0 error. So I should be okay. If this evaluate to false, in that way I know x is equal to 0. In that way, I shouldn't evaluate this. I should skip it. All right? Now, if I apply similar logic to this disjunction over here, okay? So now what will be the error condition? It would be x equals 0. Exactly the negation. How does it work? If x equals 0 is true, that means I shouldn't bother to evaluate this. I can avoid it because error condition is true. On the other hand, if this evaluate to false, I know that x is not equal to 0. In that way, I should also evaluate this part over here, in which case I know it will be 100% safe to evaluate this. Right? So the logic works for either conjunction or disjunction. Which one to use is kind of up to you, really. All right, any question about this general logic here? And then we'll see concrete example. Do some tracing, and then I'll give you one exercise to try on your own. Yes?
One quick question. How will the short circuit refer to the definitions we have in the split map on the conditions? Will it be like with multiple conditions, perhaps? Or
Sorry, say it again. I don't quite catch your question.
you mentioned earlier
Mm-hmm.
that these operators in Java are not 100% the same.
Not 100%. It's about order of evaluation from left to right. It may skip as well. Yes, go ahead. Yeah.
Okay, so, but I still don't see how they will output a different result.
We'll see. We'll see. Okay? Yeah, we'll see. Example. Exactly. All right, so that's a principle. You can always refer to it. Let's see concrete example, which is here. Okay, let's see this one here. Let's say I have some expression here that's what I call vulnerable or sensitive. Let's say this expression here. Y divided by x. I definitely don't want to run into the situation that I'm going to do y divided by 0. So the guarding constraint I have is this. I have x not equal to 0. So this is my guarding constraint. This is to say, I'm only going to evaluate this expression here if this one here is true. This one is true, meaning that x is not equal to 0. It's going to guarantee y divided by x is not going to run into division by 0 problem. Okay, let's see more clearly. Why don't we try this input here? x0, y10. x0, y10. All right, let's plug in the number. 0, which is x, not equal to 0, and y will be 10. Divided by 0, larger than 2. Of course, this is already kind of weird, right? But the thing is, at the runtime, we're not even getting there, so we are fine. If you try at the runtime, you're going to evaluate this one first. This one is going to give you false. According to short circuit evaluation, if expression 1 already evaluated to false, we are just going to return false for this directly, and we're going to bypass. So we are never going to reach this crashing situation. All right? That's really the good value for short circuit evaluation. All right? And the reason that we can exploit this is because evaluation always goes from left to right. It doesn't try to evaluate both sides. It doesn't. All right? All right, any question here? We good? Okay, let's do something very quickly for another one, and I'll give you some exercise to try. And similarly, if I still want to try x equal to 0, y equal to 10, but now I want to use disjunction. So what I have is here. So I got here. So 0 and 10, okay? 0 and 10, the same. And then I'm going to try this line here. Let's plug in the number. So x will be 0, so 0 equals 0, or 10 divided by 0 larger than 2. And if you remember this page I just wrote before, this will be so-called error condition. Error condition. In this case, it will be true. If for disjunction is already true, I'm going to bypass because the result is going to be true anyway. And then this is going to return true for the OR. We again protected the division by 0. Are we good with this? All right? And now I'm going to give you some exercise to try. All right? Remember I mentioned that the typical sensitive expression we may want to protect would be, the one I just demonstrated was the division by division. Right? I'm going to give you another one. Exercise. Okay, let's say I have array A, integer I. I want to check to see whether at that particular index the stored value is positive. Let's say that's what I want to evaluate. However, there is a potential that I might run into array index out of bound exception. Array index out of bound exception, something like that. You know what I meant, right? How do I protect it? Conceptually, I want to make sure before I even start evaluating AI, I itself should be a valid index. So I'm going to give you some placeholder to fill out. Exercise number 1, let's use the version of conjunction. Put something here, put something here, and conjunction. So it's like a P and Q and R. Exercise number 2, I want to put something here, but put OR. Something here, and OR. And then I want to have AI larger than 0. A, B, C, D. What should they be? All right. You got answer, Josh? Okay, don't say that because your classmate would like to try. I'm most likely sure you will be right, but it's good to let everybody have a chance to try. All right, try them out. Okay. Either you tried it here during off class time, or try in the test. Either way, right? Better try it earlier. Okay. If you want to go over answer, let me know. We can go over together. All right, so that's what I want to say about short circuit evaluation, to just give you the background. And now we can really use that to apply to the context of equals method, right? That's what we're going to do. All right, if you go back to the slides, we have seen quite a bit, right? Okay, this will be the next example I'd like to do. And I want to do the person class. And now if you look at the person class, it's just slightly more complicated than the point class. So rather than having just x and y integers, now we got first name, last name, reference type, string. Also, we got weight and height, double. Right? Slightly more complicated. So now what we want to do is to override the equals method from there. All right? And the idea is very simple. What you will see actually in lab number 3 and in programming test number 3 maybe later is whenever you're asked to really override the equals method, you will be given some informal description defining what does it really mean for that type of object to be equal. So here we are saying two persons are equal if their names, first name, last name, are the same, and also their measures, weight and height, are the same. So you basically can compare all the 4 attributes, right? And for this one here, let's not worry. I'm just going to give you the answer directly. It's very straightforward. Okay, so let's go over them very quickly, and I do have some questions for you to think about. Let's now take a, oh, sorry, I forgot to switch. There we go. So only look at here first, all right? So these lines are just standard. Oh, except for this one here. So that'll be question number 1, basically, right? But for line number 1, this one is standard. But line number 2 here is interesting. Okay, so where does this line come from? That's something I would like to derive for you. And then I do have a question for you afterwards. So let me just copy this guy here. Right, so that's the, that's the overridden version of the equals method in point V2. And then what I want to do is, I want to, let me create a new page over here. Okay, that should be good. Oh, by the way, there's another thing about short circuit I forgot to mention. So it would be an exercise for you to try on this particular one. So this one demonstrates to you if you actually put the order of the 2 constraints the opposite way, how is it going to crash? All right? So basically, try the same input here, x being equal to 0. If you try on this, I swap the order of the guarding constraint and also the condition we want to protect. Somehow, how are we going to get a crash, even though we got a guarding constraint? Right? Exercise for you. Okay? I forgot to mention, but anyway, let me go back here. I want you to take a look at this overridden version here, and then let's now focus on 2 lines. This line over here, and also this line over here, right? These 2 lines. I can make it a little bit bigger. Oh, yeah, like that. Right, you can see for both of these 2 lines, we are going to return false. Return false. I would like to reduce this implementation here to be 1 line only, like a 1 if only, rather than 2 ifs, because they're both going to return false anyway. Right? So I got 2 options for you, which I'm going to write down. Option A, I'm going to say if, and let me be a little bit lazy here. Let me say this is condition 1, and let's say this one here is condition 2. Okay, I'm going to say if 1 or 2. Return false. And option B, I'm going to say if 2 or 1, return false. The intention is really to reduce 2 lines into 1 line. Because I know either this condition is true or this condition is true, I'm going to return false. I want to combine into a single if. But now I got 2 options for you. Either I say 1 or 2, or I can say 2 or 1. You see the point, right? All right. Now, which one should you choose? A, B, or both, or neither? Maybe not neither. I'm pretty sure one of them is going to work. A or B? You will choose A over here. Why would you not choose B? Let me ask that way.
If I choose B, the object can be null. So 2 would be null at first, and 2 will give us a null pointer exception.
That's perfect answer. Thank you so much. That's brilliant. All right? All right, so your classmate said exactly the right thing, but let me just repeat it again. Number 2 should be wrong. I mean, B should be wrong. And A should be correct. All right? But let me see, okay, let me justify why B is wrong so you'll see why A is right. If you look at B here, for B here, this expression here is basically something like somewhere you're going to say obj.getClass, right? Somewhere you're going to say obj.getClass. And for for 1 over here, it's actually going to check whether or not obj is null. All right? That's the layout. Now, you want to ask yourself, what if obj really is null? In that case, you got to evaluate from left to right. For option B, you got to evaluate this one first because that's on the left. Now, when you're going to evaluate obj.getClass, null pointer exception right away. You don't even get a chance to check this error condition. Too late. Right? Null pointer exception. And this one here, not even reached. All right, so this at the same time also justify why option A is appropriate. Because if you look at option 1 over here, that means we're going to check obj equals null first. If this error condition really is true, we're going to return just true for this OR. We're going to bypass number 2, so we can protect it. Right? So that's the logic here. So I basically answered 2 questions over here. Number 1, if you want to collapse these 2 cases into 1, you should really choose A. Number 2, if you swap the order rather than 1, 2, you say 2, 1, you still run into null pointer exception. Right? So these are the 2 things you want to review when you review the notes. Okay? Good. So we already answered 1 and 2. All right? Now, final question here, and then we'll take a short break. This one here. Now, I want you to look at line number 11 and 12. I will highlight it for you. Let's say line number 11 here, and line number 12 over here. 11 and 12. Okay, I'll make it bigger. There is an equals method here that's being called. At this point, we actually got several options here. We got either the default version of the equals from objects. We got the equals method that we are trying to override in here for person, which is here. We also got the equals method from point v2. We also got the equals method from string class. We got 4 options here. Now, which version are we calling? Before you say anything, let me write it down. Number 1, we got the object version. Number 2, we got the point v2 version. Let's say these classes are on the same package, right? So they are also visible. Number 3, we also got the person version, which we are overriding right now. And number 4, we also got the string, which is something that you have been using in all your labs, right? So these 4 at least, all right? Now the question for you, for these 2 equals over here, which ones are we calling? It's a very typical question you have to answer for OOP. So now we're basically asking, when your code compiles, but at the runtime, you got so many options for the equals method to choose from. Which one should be chosen? Only one. By the way, it's something called dynamic binding, which we have to run into very deeply when we talk about inheritance. This is more like a little bit flavor. Okay, 1, 2, 3, 4. Which one? Yeah?
String, I think.
4, you meant?
Yeah, 4.
Okay, how come?
Because it calls dot equals for a string, type string.
Type string, which is the first name, right?
Yeah.
Okay, that's good. All right, this one is not too bad, but we might run into another one that's slightly more complicated. Today, we'll see. But this one here, let's now take a look. You really want to take a look very carefully about the line of method call here, right? Let me write it down. You basically got this dot first name dot equals. And then, of course, you got something else over here, right? Now, how do we analyze this? This one is simple, but let me still do it. But when we get to the more complicated one, you will just have to extend your reasoning slightly. So what's this? This corresponds to the current class that we are talking about, which is person. And in the person class, we do have something called first name, and then we got string. All right, over here, we got first name over here, and then string. And then we got the equals method that's being called. So the equals method must be on the string class. All right, that's kind of the reasoning you have to do. And notice that the dot notation may be arbitrarily long. So you have to know how to go from leftmost to rightmost until the dot before the equals. Right? That's something we'll see either today. There's another more complicated example which we will see either today or maybe Tuesday. Okay? All right, so that's really the thing you want to notice that, right? Notice. All right, any question about this? If no, why don't we take a very short break by taking attendance, and then we'll continue a bit. If you can get your iClicker ready. All right, I only got about 7 minutes. I'll see what I can do. So there's only one more example I'd like to do for the equals method. So let's now see how much we can do. I can do the most interesting bit first, and then we can talk about some other things very quickly on Tuesday. But let's now see the slides. All right, so this is the last example for the equals method, right? It's going to compare a class, well, it's going to override the equals method in another class called person collector. That should be no surprise, right? Person collector is going to store an array of person and some NOP, number of person, okay? Let's now take a look at the class first, and then I want to explain to you visually how you can understand the equals method, okay? So we got a class person collector here, and persons is just an array of person. We got number of person integer counter, and then that's it. No other attributes. We got constructor, we got mutator add person, also get the value for these private attributes, and also get a person, right? Everything is what you did before, so nothing surprising. And your job, which I'm going to show you directly the solution, is to redefine or override the equals method in the person collector class. We don't really want to use the default version from the object class, so equals here. So these two lines should be standard. I'm just using what we discussed before the lecture. All right? So that's something you can also review. So these two lines are just standard. And this line here basically is already phase number 4. We're going to cast the parameter from objects into person collector so that we can invoke methods such as get NOP or get persons, etc. Right? The same logic as we did earlier. And for this fragment of code over here, that is something we have to study. All right? So it will be an exercise for you before Tuesday to really look at the logic here. And I want to use the remaining 5 minutes for something else. So I want you to focus more on this Boolean variable equal here. And then that one there is assigned to be false to begin with. And somehow it's reassigned to be true over here before the loop. And we are using the equal as part of the condition for the loop over here. And then we're going to reassign the equal to something every iteration of the for loop. And finally, we're going to return that Boolean flag. This is one way of doing the equals method. You can feel free to copy this pattern here. That's not a problem. You may decide to use continue or break, whatever, but that's not so recommended. People actually argue that if you use break or continue, you're going to result in something called spaghetti code, which is not very good software engineering practice. So I would discourage you from doing that. You should really try to use a Boolean variable like what I'm doing here to control the entrance and exit from the loop. That's the principle. So one exercise for you, you really want to study this one here. So when we do the tracing on Tuesday, you will be able to understand better. But I want to use maybe just a few minutes to talk about this line over here, just this line. Just this line. As you can see in here, this line here, we are calling the equals method. But now we want to know which version of the equals method are we calling. This one is actually more complicated than the one we talked about before the break. We got so many options here, from objects, from point v2, from person collector, and from string. We got 5 options here. Right? Let's not guess. Can anybody say first which one should be? And then we'll analyze it, and then we're done. Go ahead. Should be person? Okay, that's pretty good. Well, I'm pretty sure you didn't guess. You simply analyze it. All right? All right, so that'll be the last thing I'd like to talk about today. And I'm just going to copy this down here, and then bear with me, about 3 minutes, we'll be done. So it would be something like this. So it would be this dot persons I, and then dot equals. And then something here. All right, let's analyze it very quickly. If we start with the this is really corresponding to the current class overriding the equals method. That one should be person collector. Let's start with that. And then if we do this dot persons, we know that persons is declared to be an attribute here of type person array. So that would be person array. All right, so far so good. And then we are trying to index into the array using some value I. So now if we try that, it's going to be this. And that one there is going to give me just a person. And you can see afterwards you got equals. So that's why this equals method here is actually going to be calling the person version of the equals method, which we talked about before the break. All right, it's another important analysis for you. Okay? And one question here. How to modify this line to invoke equals from the string class. All right, this will be one question I would like you to think about when you go over the notes, maybe over the weekend. All right, now I want to go further to say I don't want to call the equals method from the person class, maybe from the string class. How can I do that? Alrighty, thank you so much. If you still want to drop by my office hour today, 3 p.m., I might see you there. Otherwise, I'll see you next week.